Okay, 4.2, the nature of the chemical bond. So we know that the the location of this electron is not specifically known to scientists. They use cloud of the electron. So for example, hydrogen has one electron, so it's nucleus, and the cloud of electron is like that. And you know the electron going to be in 1s orbital, you have one electron. Then you have CO2, I believe this is CO2. Sorry, this is CO. So this is F atom. This F atom, you know, it has okay, sorry, my bad. This is a hydrogen atom, and here is another hydrogen atom. So it's a single electron here and a single electron here. They want to come and bind together to form H2. That's why the cloud of electron will be shared. As you see, the cloud of electron, when they share, they will be evenly distributed around that. Now, this is the hydrogen atom. As the last electron that is unpaired in a fluorine is in a p orbit. That's why the shape of that is dangling. Now these two electrons want to be shared. They share it, so this slope kind of become like that is bigger. This is HF bound. Okay. Now for oxygen, I know that it has 8 electrons, right? Totally 1, 2, 3, 4, 5, 8 electrons. Maybe 1s2, 2s2, 2p4. These two electrons are unpaired that contribute in a bond. As you see, this is oxygen atom. We have 2 of these electrons unpaired. So this hydrogen comes here and this hydrogen comes here, and then share cloud of the electron, and eventually they look like that. So you can do question question number 4. Now we're doing the hybrid orbitals. Okay, we'll see what is the hybrid orbitals. Okay, the example that they did here is BF3. Maybe I really do that. I'm going to do the example of a CH4 to explain what is the hybrid. So for carbon, if you do the electron configuration, you know, you have 12 electrons in the valence, right? So it's going to be 1s2. So we have a 2 electron here. 2s. And 2p. For carbon, we have 6 electrons, right? So we have 6 electrons, 1, 2, 3, 4, 5, 6, right? Purina has a 3 of that. Okay, now we want to make CH4. CH4, everyone knows that making 4 bonds. These 4 bonds are equal and same bound with hydrogen, right? And everyone knows hydrogen is just 1s, and here is just 1 electron. You have 4 of them, so we just have 2 electrons there, right? That's unpaired. So how come I need to have a 4 unpaired electron to make bound with 4 hydrogen? That's why the hybrid happened. As you see, these two levels of the energy need to be combined. When they combine, the energy level will be a little bit between these two. So how many boxes is this? 1, 2, 3, 4. 1, 2, 3, 4. And then I will distribute these electrons here. See, 1, 2, 3, 4. 1, 2, 3, 4. So this is the hybrid. We need to form hybrid in order to make a four same bound here. Now, one of this will be bound with one hydrogen, and here with another hydrogen, and how I come and make bond with that. We have 4 bound with hydrogen around carbon. Same thing I can show for BeH2. So Be has 2 electrons in s orbital, but they are not single. That's why it's moving into the higher. They combine itself with the p orbital. When they combine, this electron will be distributed evenly. Now here going to be sp, right? So this is sp. This is going to be sp hybrid. Means one of these orbits is from p, and one of that is from s. That's why it's going to be sp. BCl3. BCl3, as you know, again, you have a 3 electron, 2 of them is s and 1 of them is p. They combine. One of the electrons is from s orbital. When they distribute and they make a hybrid, it becomes like that. But one of these circles or box coming from s, and 2 of them coming from p orbital. That's going to be sp2. CH4 is the same thing. Now, when they make a hybrid, 4 of them I have involved. One of that is from s orbital, and 3 of them is from p orbital. That's why it's going to be sp3. Now, so for BF3, so B, if you do the electron configuration, it's going to be 1s2, 1s1, 2p1, I'm sorry, 2s2, 2p1. Let me just do that. Here is 1s, here 2s, there is 2p, 2 electron there, opposite side. Here is 2 electron, and then here is just have 1 electron, right? And they want to, it's going to be BF3, means I need 3 available things. So these two combine, 1, 2, 3, 4. And here is 1 electron, 1 electron, 1 electron. Now, this is 3 available bound with F. As you see, what is that? One of these boxes is from S, and 2 of these boxes coming from, so it's going to be sp2. And how about F? If you do F, it's going to be 1s2, 2s2, 2p4, to be 2p5. Let me just do that here. 1s, 2s, 2p, right? Okay. 1 electron. So this 1 electron will come and paired with that. I have another F. I have 1 electron will pair with that, another F coming in and pair with that. So these all three are in p orbital. But don't need to make a hybrid for that. This is the central. I don't really need to make a hybrid for that. The same thing you can do for PEH2. So you can question number 10 and question number 11. Now, double and triple covalent bond. Now, what's gonna happen here? For this one, we did like H2, 1s and 1s combined with that, and two p orbitals come and involve. This is like that. And let's say sp3 and sp3 hybridization happening. You have like that, just sigma bond. I'm gonna go through an example. See what is the example here. Here is so sigma bond, a bond created by the end-to-end overlap atomic orbital. When you have a single bond, it's going to be sigma. But if you have a double bond or a triple bond, it's going to be pi bond. Now, we'll do an example, I guess. The good example is, I think, C2H4. Okay. Here we have C2 means two carbon attached to each other. Now two hydrogens here and here. Okay. Okay, so let's just, again, we have 6 electron. That one has a 6 electron. So it's going to be 1s. You have a 2 electron. Here, 2s. 2 electron in that. And 2p. See, we wanted, again, the hybridization because we have 2 equal bonds, right? 2 of this electron, oh, sorry, 3 single bound we have, and here is double bound. That's why just 3 of them need to combine here. And this double bound will remain here. So I'm distributing the electrons. See, this remaining a double bond will remain that. So what do we have? One of them is from S, so it's going to be sp2. And this double bond going to be what? Remain in the p state. Okay, as you see, this is remaining in the p state, so this is sp2 is there a single bond. So the single bound is going to be sigma. So see, this is sigma. This is sigma, that is sigma, but double bond, we call it pi bound. So here we can have a triple bound. For triple, okay, let me just do the triple bound as well. For triple bound, the example gonna be C2H2. C2H2. So we have a 2 carbon connected to each other. We have hydrogen here. We have hydrogen here. First, there is going to be triple bond between the carbons. Again, going to be 1s, 2 electron here. 1, 2 s, 2 electron here, 2p, because I have a 2 single bond around carbon. I just need 2 of them to be hybridized. So, sorry, I just need to make it in the middle of them. Right, hydrogen and happen, the energy level will be 2 of them here, right? And the other 2 remain there, and the electron will be distributed. So these 2 is the one that is single bond here, that is sigma bond here, sigma. But the double bond at triple bond will, the one that you see it is there. These 2, we call it pi bond. Both of them, double bond and the triple bond, are pi bond. But this is, one of them is from S, one of them is from me, this way is SP. And this is just remain in P state, right? So we can do number 20 here. Okay, so triple bond, I did explain that here, but you can look at these pictures and do number 26. Oh, not 20, 27.